So, how will you prove the Snell's law from this Fermat's theorem? Fermat's theorem states that consider a light ray AO incident at the point O. Let this be the line separating the two medias 1 and 2. So AO is the incident light and OB is the refracted light. Fermat's theorem states that light travels from or between the points A and B such that it will consume the least time. So AOB is a path in which the light travels in such a way that it will consume the least time. So the total time taken from by the light to reach B from A will be, let's take that total time T is equal to time from A to O time AO plus time taken to reach from O to B time TOB. Suppose let V1 be the velocity of the light in the medium 1 and V2 be the velocity of the light in the medium 2. Then we have time is equal to distance divided by speed. Therefore implies T is equal to, we have TAO is equal to distance is equal to AO divided by speed at the first medium is V1. Similarly, TOB is equal to OB divided by V2. Now, since this AMO is a right angled triangle, we have AO is equal to root of this AM square plus MO square. We took AM equal to A, and that is AM square plus MO square. That is equal to root of A square plus MO, we took that as X square. Similarly, OB equal to, OB will be root of, again use the Pythagoras theorem, Bn square plus No square. Bn square plus No square. We have Bn square is equal to B square plus No will be, we took the whole distance Mn equal to D and this Mo equal to X, so this distance will be D minus X. D minus X whole square. Now substitute these values of AO and OB. Let's call this as equation 1. In the equation 1, you will get T is equal to, instead of AO, you can write root of A square plus X square divided by V1 plus root of B square plus D minus X whole square divided by V2. So this is the expression for time. So according to Fermat's theorem, since the light consumes least time, the derivative of t dt, derivative of time with respect to displacement must be 0, since it consumes least time. So we have to derive the equation, let's call this as equation number 2. We have to derive the equation with respect to x and put the value as 0. So this will be derivative of d by dx of root of a square plus x square divided by v1 plus root of b square plus d minus x whole square by v2 equal to 0. Clear? Therefore, this is equal to, this v1 is constant, we can take that outside, 1 by v1 into derivative of root is equal to 1 by 2 root of a square plus x square into, again coming into the values inside the root, derivative of 2x will be 2x, x square will be 2x, plus again this v2 is constant, 1 by v2 into derivative of this one root, again it is right here, plus derivative 1 by v2 is constant, 1 by v2 into derivative of root again is 1 by 2 root 1 by 2 root b square plus d minus x whole square into derivative of d minus x square is 2 into d minus x. Again derivative of minus x is equal to minus 1 equal to 0. So you can cancel this 2 and this 2 and this 2 and here you get a 2. So you can cancel that. So the final expression will be 1 by v1 into x by root of a square plus x square equal to, since there is a minus 1 in here, here it will become minus, and if you take to the right side it will become positive, equal to 1 by v2 into d minus x divided by root of b square plus d minus x whole square. So this is the expression you will get. Now look at the triangle AMO and BNO. If this angle is I, definitely this angle will be I, since these two lines are parallel. Similarly, if this is R, this angle will be R. Now let's look x divided by, this is x, and this length is equal to, we have root of a square plus x square. So x divided by root of a square plus x square will be the sine of angle I, sine equal to opposite by hypotenuse. So this will be 1 by v1 sine I equal to, similarly this length is equal to, this length in OB, we have OB equal to b square plus d minus x whole square. So ON, this length is d minus x. So d minus x divided by root of b square plus d minus x whole square will be sine of angle R. So 1 by v2 sine R. So rearranging, we get sine I by sine R is equal to v1 by v2. Actually this one is the Snell's law. This is the Snell's law, or sine I by sine R, and we call the ratio of the velocity in the first medium to second medium, we call this one as the refractive index of second medium with respect to first medium. So that's the Snell's law. That's the way we derive Snell's law from the Fermat's theorem.